Hello, Algebra 2. Welcome to CFR2 Guided Notes. We're looking at characteristics of function graphs. So what do I mean when I say characteristics of function graphs? What we're looking at, we're trying to identify the attributes or what the function looks like by looking at its graph. There's a few different characteristics that we're going to quickly identify and describe. We have very specific ways to describe these functions. So let's go ahead and take a look at this thing. If I'm reading this kind of like a book, right? I'm reading my function like a book. I'm going to read it from left to right. I'm going to read it from left to right. I would say, so it starts down here, right? If I was reading left to right, it's increasing, it's going up, then it hits this hill and goes down, then I get to a valley, go back up, then another hill, then another valley, and then eventually I'm just going to keep going up to positive infinity in y, but I'm also going to go to positive infinity in x. Right, that's kind of what we learned and talked about in CFR1. But in CFR2, we got a few other things that we're going to talk about here and different ways to describe it. A little bit different than what we did for CFR1 for domain range and end behavior. So what we're going to do, like I said, we're going to make sure that we read the function. So read the function graph, read the function graph from left to right. From left to right. And if you looked already, if you've seen this, there's multiple pages here. The first page has 4 descriptions. The second page, I think, has 4 descriptions too. Yep, 4 descriptions also. So if I'm looking at that, we're going to talk about these in 2 separate ways. What I want to do is start here with what's an increasing interval. What is an increasing interval? And how I'm going to do that is we're going to start at the beginning. Well, you know, the first time we see the function, and I'm going to put a little mind card on here. Little mind cart. You got Mr. Raymond standing on the mind cart, right? And if I'm thinking about an increasing interval, I'm saying, where's the function going up as I'm reading from left to right? And now when I say the words up is interesting. Up and down indicate y-axis. So we already have taken care of the y part of things. We know it's going up, but we don't know where in x that it's going up. So that's what we're going to describe. So increasing interval is, where is this function going up? Where is this function going up as described by x values? Where is this function going up as described by x values? So in other words, as I'm kind of on this my cart here and I'm riding my roller coaster, it's going up until I get to right here. Where is right here? Well, that's -6. I'm starting going up from way back here. This is negative infinity. So this is going up from negative infinity to -6. I'm also going up from right here to right here. And then also going up from here all the way on out, all the way to positive infinity. It keeps going up from here. But we're going to, again, we're describing an x, because going up and going down takes care of the y values. So we're going up here with purple. So from negative infinity to -6 is an increasing interval. And I also increase when x is -4 to when x is 1. Again, when we're saying up and down, that is taking care of the y values. We just want to report the x values. Okay, so from -4 to 1, it's also going up. And then it's going also up from 6 to positive infinity. Now you'll notice something about this. I put these, there's not coordinate points. Okay, they're not coordinate points. These are pieces of the domain. These are interval notations of the domain. Interval notations of the domain. interval notations of the domain. That's what these are. These are not coordinate points. These are not coordinate points. These are interval notations of the domain. So I was going up from here to here, here to here, and here on. I was going up for. The decreasing interval is just the opposite, right? Where is it going? Down. Where is the function going down? Let's go ahead and do a different color in here. Go with this one right here. Where is the function going down? Yeah, let's get that a little bit apart there. Going down as described by x values. So let's look. Let's see where it's going down. What's going down? I don't know. All right, so it's going down from here to here. It went down. And then from here to here, this function is going down. And that's the only time that the function's going down. So if we use those x values to give our x interval, our domain pieces there, it's going down between -6 and -4. And it's also going down between 1 and 6. And that's how we take and describe those things. Where's the function going up as described by x values, brackets, right? And where's the function going down? In other words, if I wanted to say, I want you to take a chunk out of this function by just using the x values, where is it going up? Well, I'm going to say it's going up from -4 to -4 to 1. So if I took it between x from -4 to 1 out, this function would be going out. I'm sorry, going up, right? That is increasing and decreasing intervals. And again, just like I said, it's going up and then we got this hill down in a valley, then it goes back up and then it goes back down, right? So we got this other description part of relative or local maximums and relative and local minimums. What does this mean? I think this is pretty interesting. Let's go ahead and do a different color here. We'll go blue. No, not go blue. No, I forget I ever said that. Don't go blue. Okay, the relative or local maximums, those are our hills. And notice how I'm saying relative or local. I'm not saying the maximums, right? I'm not saying follow this arrow to positive infinity. I'm saying, where are my hills? Where are my hills? In other words, where the function changes from increasing to decreasing. From increasing to decreasing is a hill. Make this bigger so I can write it out. This is where the function is changing from increasing to decreasing, just as we described up above, from increasing to decreasing. And now this is one that's interesting, because before we were using interval notation. That's why it's intervals. Part of the reason it's intervals. We're using this interval notation to describe our x values. It goes between two x values. Well, at this point, we need to know the location and the value of the hill. In other words, we need to know the location of x, of where it happens, and then the value in y of where it happens. This is going from increasing to decreasing. Do you see one more hill in here? I sure do. Right there. This one has two hills. In other words, we have a value of 4 at x equals 6, -6. So we have 4 at x equals -6. And we also have a value of 5 at x equals 1. 5 at x equals 1. Those are our two hills. Yes, you could put those in coordinate points, but I'm trying to make it so you don't get the intervals confused with coordinate points. Yes, you could write -6, 4, but remember that that's different than these up here. That's different than the intervals. You could also write this as 1, 5, but that's different than what's up here. Right? Those are not intervals. That's an actual coordinate point. So these up here, not coordinate points. Not coordinates. And these down here, these are coordinates. Chords. Those are coordinates. Well, if the relative or local maximums are hills, and we've kind of already figured this out, right? The minimums, the relative or local minimums, those are going to be my valleys. And notice how we're not talking about what's happening at the ends. Why are we not talking about what's happening at the ends? Because we've already done that. That was the end behavior. That was end behavior. Right now we're describing kind of what's going on in the middle here. Okay, so we've got our valleys here. So where the function is changing, and this time with a valley where the function is changing from decreasing to increasing. Decreasing to increasing. And again, these are the valleys. Just think of this as the valleys. So I've given you both the math definition from decreasing to increasing, but I've also given you kind of the term that we would like to use, right? The valleys, the low points. Notice how we're not saying the ends, we're just saying, where are the valleys? So my valleys are when it's a value of -3 at x equals -4. So -3 at x equals -4. And we have a second value in here, -4 at x equals 6. And again, you could write these as coordinates, just don't get them confused with the intervals and using interval notation. You could have also written this as -4, -3, and this one as 6, -4. All right. That is the first part. That is the first part of what we were doing. All right. So go ahead. We'll make this part 1, and we're going to go to part 2. We can do it at the same time. I'm going to do it at the same time. All right. So watch them how you need to. This is the end of part 1.